friends, in today's video we're going to discuss about the basic concept of a transformer. In near future videos, in further videos, we'll discuss about the theoretical explanations of a transformer, but in this video we are going to make the basic idea, basic concept about a transformer. So what is a transformer? We all know that transformer is an electrical machine. So transformer is an electrical machine. We all know that. And what type of electrical machine? It's a stationary stationary machine. That is, it doesn't rotate. It gets stand. It get it gets stand, or it's a stationary machine and it doesn't rotate. Okay, so in case we have seen the motor or generator gets rotate. So those electrical machines are called rotary machines, but transformer is called stationary machine because it doesn't rotate. Okay, so what does a transformer do? We all know that transformer transforms transforms what? Voltage. It transforms voltage. That is why it is called transformer. So transform voltage, it may up the voltage or down the voltage, right? It may increase the voltage, or it may decrease the voltage. So depending of the situation, well, whether it is increasing or decreasing, it is called step up and step down transformer. Okay, so if it is increasing the voltage, then it will be called step up transformer, and if it is decreasing the voltage, it will be called step down transformer. Okay, so it is increasing the voltage and decreasing the voltage, but what about the current happening in a transformer is also increasing or decreasing the current also. Okay, because we know voltage is inversely proportional to current. V varies 1 by I. Voltage is inversely proportional to the current. So in case of transformer, if the transformer is increasing the voltage, then the current will be decreased. Okay, if transformer is increasing the voltage, then the current will be decreased, and if the transformer is decreasing the voltage, then the current will be increased. Okay, so these are inversely proportional. So if I say about a step up transformer, it will increase the voltage. In case step up, it will increase the voltage but decrease the current. And in case of step down transformer, it will decrease the voltage but increase the current. Okay, so we got about the situation of current and voltage. So what about the power? Whether it will increase or decrease, power will remain same. In not just in a transformer, if any machine is there, any machine in the world will remain the power same. So what is my point? Let's get understand. In a machine, it may be any machine, not just a transformer. If you give an input here, you will have an output. I didn't say that input will be always equal to our output. I didn't say that. Okay, I said that the power you are inputting there, and your getting the power will be the same. So what is the point here? You are giving an input and the machine will have some output and also some losses. So input is equal to output plus losses. What type of loss? If you give input in a machine, it will make some losses. Okay, every machine will have some losses. So after doing the losses, you will have the output. After doing the losses, doing the loss, it will have an output. So input is equal to output plus losses. So what type of losses we can see in a transformer? Like this is a transformer, that is it's made of iron core. It's a iron core, and copper wires are wounded like this. Maybe this is called a primary winding. Let's suppose this is a primary winding, and this is the secondary winding. So primary and secondary. So these are copper wires. Okay, so these copper wires are wounded in the core of the transformer. This is a iron core. This core is a iron core, rectangular shaped core, suppose. And these copper wires wounded, or these copper wires are the windings. Okay, so there are two type of losses can happen in a transformer. Two type of losses. What losses? The in a copper wire you can see the copper loss. Why it is called copper loss? Because in electrical machines we generally see the wires are generally made of copper. Wires are generally made of copper. So that is why it is called copper loss. It may, in some cases, the machine, maybe you have seen any motor where the winding is made of aluminum, but also it will definitely called copper loss, not aluminum loss, because it is a standard. It is called copper loss. Okay, the loss happened in the windings. It is called copper loss. And there is another loss that is called core loss or iron loss. Because the core is generally made with iron material, that is why it is called iron loss or core loss. And we can say the formula of copper loss is I square R. So I is the current flowing there, and R is the resistance. Maybe let's take R1 is the resistance of the primary winding, and R2 is the resistance of secondary winding. I1 is the primary current, and I2 is the secondary current. So I is the current, and R is the resistance of the winding, and I square R. If we write I square R, it will make the copper loss. So copper loss is I square R. And core loss, in a transformer there are two type of core loss. In the core we have two type of loss: AD current loss, and hysteresis loss. AD current loss and hysteresis loss. Okay, so we'll go in a detailed discussion about eddy current and hysteresis loss in our further videos. But shortly, briefly, we understand here that copper losses are two types: eddy current and hysteresis loss. So to reduce the eddy current loss in a transformer, we use laminations. You see, you in an electrical machine, maybe it's a transformer or generator or motor. You see the core is not a single bar, rather than it is it is normally laminated. Okay, you maybe you have seen there are thin layers so many thin layers one by one, and it is wrapped, and all the layers are insulated, electrically insulated from each other, and using what, a a lamination, a coating maybe a insulated coating, maybe polish or resin type. Okay, so all the laminations are done, and the laminations are coated using insulation. Okay, from each other, electrically isolated from each other, and one by one laminations are done to reduce the eddy current losses. And there are another loss called hysteresis loss. So to reduce the hysteresis loss, we use highly highly permeable material. We use highly permeable material to reduce the hysteresis loss. Highly permeable means which permits or which allows to flow flow the magnetic flux through the core. Flow which allows or which permits to allow a flux to flow through the core, and these materials are called highly permeable materials. Highly permeable, that is, iron is a highly permeable materials. Okay, and if we use some other material here, then it will not be permeable, and it will not permit the flux to flow. So iron or nickel, these are the highly permeable materials. Okay, stainless steels, these are. So in this video we have discussed about the basics. We have discussed about the basic concept of the transformer. If you like the video, please do subscribe this channel and like and share. Thank you. And in further videos, we'll go about the details of the transformer. Okay.